Not yet. We'll see. So, ladies and gentlemen, continuing now, let's consider, now that I can map the unit circle and draw a little triangle and blah, 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 let's see if we can find the exact value ladies and gentlemen, please. Let's find the exact value of, how about cosine of 120 degrees? Cosine of 120 degrees. So the way I'm going to do this, let's draw, terrible. That's a little better. Not amazing. A little better, though. Let's draw a 120 degree angle. Where's 120 degrees? Which quadrant would that be in? Quadrant 2. All right, so 90 degrees and then 30 degrees more than 90. It'd be somewhere like that, right? So here is 120 degrees. Right? So assuming this is still a radius of 1. All right. Here I've got that, and it's a right triangle. So here's my ordered pair x comma y. Right? And the radius, like I said, we'll keep it 1 for now. All right? So imagine this being on the unit circle. If I want to figure out cosine of 120 degrees, cosine is going to be the ratio of what to what? Cosine is the ratio of adjacent over hypotenuse, right? So I'm trying to figure this out. And in this triangle, I just want to point out that the ratio of adjacent over hypotenuse, how many units is this overness here? How many units? X units, right? And is x a positive or a negative number? Negative. So it turns out in quadrant 2, cosine angles are negative. Cosine is negative in quadrant 2 because it's to the left, right, of the origin. Right? Does that make sense? So now we don't know cosine of 120, but if I want to figure out the ratio of this to this, I can work within this triangle, right? And what angle would this be? Right? I can find the reference angle by doing 180 minus 120. Now this particular formula only works in quadrant 2, I want to point out. And I find out that that's a 60-degree angle. Right? So cosine of 120 degrees is going to be the same as the negative. So let's see, cosine of 120 degrees equals negative cosine of 60 degrees. Now I have to specify that that's negative because cosine of regular 60 degrees would have been up here, right? And that would have been a positive x value over here. Yeah, it kind of is, yeah, exactly. So I can rewrite it in terms of the reference angle, and I consider the sign it is based on which quadrant I land in. And does anyone remember what cosine of 60 degrees was from yesterday?
I could look, but I don't know what.
It turns out cosine of 60 degrees is 1/2. So this is negative cosine 60 is negative 1/2. And I can actually figure that out. Now question, follow-up, what is sine of 120 going to equal? Let's consider. So sine is the ratio of what to what? Opposite and hypotenuse, and from this angle's perspective, the opposite would be the y value for the hypotenuse. And is y positive or negative in this quadrant? Positive. So sine in quadrant 2 is positive. So sine of 120, I think, will be the same as the positive sine of what angle? 60, because it's the same exact reference angle. Does anyone remember what the sine of 60 was from yesterday?
Oh, I know. It is square root of 3 over 2.
Square root of 3 over 2.
And actually becomes Sean's best star.
Indeed. So I just want to point out, I can rewrite these in terms of their reference angle, and then the sine is going to be determined based on which quadrant I'm in. All right? What? What's up?
Why is there no bingo?
I don't know. It doesn't happen a lot. That's all.
Why are you doing sine of 120? That's the first one, right?
Well, this was like part B of the question.
What are you asking? Part B.
I said, what is sine of 120 degrees? Sine of 120 degrees, opposite over hypotenuse, so that would be the y over 1. And the y value here would be positive, so that determined that. And the reference value here is still 60 degrees, so I changed it to positive 60 degrees, is the idea. Because we do know what sine of 60 is, but we didn't know yet what sine of 120 was. Sine of 60 we learned yesterday. Well, didn't you help me find 60 degrees a moment ago? Right? 60 degrees was the reference angle, alpha. Right? Well, it's the same angle, right? 120 degrees, 120 degrees. They both have the same 60-degree reference angle.
How would you picture sine or cosine back from what's that line?
Sine is the ratio of y, the opposite here, over the hypotenuse. And that ratio is apparently the square root of 3 over 2. Cosine is the ratio of the adjacent over the hypotenuse. So cosine in this case is 1 to 2, and in this case it's negative 1 to 2 because x was in the negative direction. Now, so let's just consider real quick, what are the sines? Sines of cosine and sine. Am I right? Sine. I didn't pick up on that. That's funny. I should just plan on doing that all the time. Am I right, guys? Am I right? So let's consider. All right, let's do cosine over here. So cosine of theta and sine of theta. So remember, cosine is equal to x. Sine is equal to, man, that's a terrible x. Y. So for quadrant 1, right, 1, 2, 3, and 4. For quadrant 1, are my x values positive or negative? Positive, because it's to the right of the origin. Quadrant 2, are my x values positive or negative? Negative, because it's to the left, right? And that's what we just found out up here a moment ago, right? Cosine is negative in that quadrant. For quadrant 3, would cosine of theta be positive or negative? Negative and positive for quadrant 4, because it's to the right, correct?
Correcto.
Correct. So let's see. For sine, quadrant 1 is positive, right? Because it's above. I moved up. Quadrant 2 is also positive. And then negative and negative, because these are down. I moved below the x-axis. And if sine is equivalent to the y value of a particular point, then it would be negative in quadrants 3 and 4. So in terms of finding particular values, we're going to combine this and reference angles in order to do so. It's okay. Oh, you didn't, man.
Okay,
Oh, you
if I
guys
do
were.
my quiz, then
You guys were way behind. I'm sorry. I don't have time.
I'm blaming this program.
That's fine. You can watch the video later. Example.
I won't take anyone else.
You should. Settle down, friend. Example. Let's figure out what is sine of, how about this? 210 degrees. Let's find the exact value of sine of 210. So let's draw a picture. Good idea. Yeah. Yep. Good idea. I mean, drawing a picture is a great idea. First of all, which quadrant is 210 in? Third. It's bigger than 180. How much bigger than 180 is it? Yeah, by like 30 degrees. So I'm drawing an angle. Maybe it's like this. So here's my 210 degree angle. And for this quadrant, the x would be negative, right? Well, it's whatever the x value is, but that number is negative. And the y value is going to be
I don't know. I should have taken notes from my.
also negative because that moved down, right? So left and down, it would be a negative comma negative for the x and the y. So sine, do I expect sine to be positive or negative? Negative, because sine is equivalent to the y value, and I moved down. So in this quadrant, sine would be negative, right? This point would be negative comma negative down here. So x is negative, so cosine's negative, y is negative, so sine is negative. It's like a snowman.
Looks like a Megatron.
Anyways, so sine of 210 degrees, see how I dyslexified that there. I don't know what that is, but what is the reference angle here? Is this the reference angle? No. Is this the reference angle? Is this the reference angle? Where is the reference angle?
The other one.
Oh, this?
Yeah. No.
The reference angle is the acute angle from your terminal side to your x-axis, right? So how do I find alpha in this case? My reference angle. Nope, that is incorrect. I take my angle, 210, and subtract 180. So in quadrant 3, this is a little formula I do.
You can only do that in quadrant 2.
Well, in quadrant 2, I would have done 180 minus my angle. In quadrant 3, I do my angle minus 180.
What would you do it from quadrant 1 or 4?
Quadrant 1 would just be whatever my angle was. The reference angle is the same as the angle. And in quadrant 4, it would be 360 minus my angle to find this amount. So I'm expecting, guys, that sine of 210 is the same as the negative sine of 30 degrees. All right? So what is that?
Oh, I know.
Sine of 30 degrees we know from yesterday. Sine is 1/2 at 30 degrees, so negative 1/2 would be the ratio for sine of 210 degrees. All right? Well, they abbreviated all of them to 3 letters. So, like, because cosine is more letters, tangent is more letters, cosecant, secant. Yeah, it's just 3-letter rule of thumb. And actually, the letter E will mean something else entirely different later.
Extra?
Nope. I wish. So, all right. So let's see. So we figured out we can now determine the values of sine, cosine, blah, blah, blah in different quadrants. And let's actually even talk about other trig ratios. So all of the trig ratios on the unit circle. Let's draw the unit, trig ratios on a circle, I'll call it. Because this one will not necessarily be a unit circle. So let me draw a quick sketch, and then we'll figure out all 6 trig ratios from this perspective. So, I'll do some non-45 degree value. So the point would be at x comma y, right? The radius is now not necessarily 1. That's why I removed the unit circle there. So the radius is r, okay?
Which equals 1, right?
So if I drew the right triangle, no longer in this case because it's not a unit circle. So what is, from theta's perspective, what is the adjacent side's length? X, and the opposite side's y.
I should become a math teacher.
You should. So sine of theta, cosine of theta, gentlemen, tangent of theta. Well, what ratio would sine of theta equal here?
Wait, I know this.
Y over r. Right, because it's opposite over hypotenuse. Cosine would be the ratio of what to what? X over r. Tangent would be y over x. Cosecant. Cosecant's the reciprocal of which function? Sine. So it's r over y. Secant is r over x.
And x over y.
And cotan?
X
X
over y.
over y.
Oh,
Right? The y got cut off here. Yeah. Settle down, friends. So, and then also, I just want to point out that there's this additional fact that we know is that x squared plus y squared is equal to the radius squared. Sometimes my r's look like square roots. So those are a bunch of facts that are true about any particular point on the coordinate plane for circles that aren't necessarily unit circles. All right. So let me teach you guys this hand trick. Hand trick. Here we go. To help you guys memorize these different values of sine, cosine, and tangent, yeah, that's what I'm going to do. Well, actually, I might draw a picture.
No, that's hard.
Well,
Just put your hand in the tablet and draw it.
I don't know.
so let's see. This is called the hand trick.
I never learned it. What, the 9? The 9 thing. I never learned it.
Okay.
I learned it last year.
So guys, here, check this out. So I use my left hand for this. So here's my thumb and my 4 fingers. I'm like, my hand is super fat. This is the thumb, right? Now what I'm going to do is label my fingers. This is 0 degrees.
Okay, so let's see here.
This is 30 degrees. This is 45 degrees.
30 degrees.
You don't need to repeat.
35 degrees.
Yeah, that would be cheating.
Oh, you said 35.
And it turns out that this is what we'll do. All right, this will not help you with the sign of our values, but it will give you at least the reference angle outcomes
I got it.
for our special right triangle. So if I want to figure out, for instance, sine of 30 degrees, then I would put my 30-degree finger down. All right, so imagine this finger is bent down, right? All right, so here's my 30-degree finger. There's my gross pointer finger thumbnail. Nope. That'd be weird if I had my thumbnail surgically removed and tacked onto my finger.
On the inside.
So you'd put that finger down. So, I just opened up. Nope. So, if you want a reference, I would have, my hand would look like this. I'd put my 30-degree finger down, and it turns out sine will be the square root of the number of fingers to the left.
1.
There's 1 finger to the left. So what's the square root of 1? 1. And then divide by 2.
By 2. By
1/2. All right, so let's see this.
Oh, by 2.
So watch this. Let me define this. So sine is equal, so sine of your angle is equal to the square root of the number of fingers to the left, number fing left, divided by 2.
Why 2?
Just cause, that's the rule.
Is it always by 2?
Yep. And cosine of that angle will be the square root of the number of fingers to the right.
Divided by 2. That's amazing.
Correct.
So that'd be 3 divided by 2 and 1 divided by 2. I'm right.
Incorrect. So with that in mind, let's check this out. Here, I'll pull up my camera again. So if I want sine of 30 degrees, let me even lift that up higher. There we go. Sine of 30 degrees is the square root of 1 over 2. All right, that's my 30-degree finger. Put it down. Sine our fingers to the left. Square root of 1 is 1. 1 over 2 is 1/2. Cosine of 30 degrees, there are 3 fingers to the right. So the square root of 3 over 2 is the value of cosine at 30 degrees. And it works out. Here, let's do another one. Let's figure out what is cosine of 60 degrees. So where's my 60-degree finger? The ring finger. So I put that down. How many fingers are to the right? 1. So cosine of 60 degrees is the square root of 1 over 2, or 1/2. What is sine at 60 degrees? I put my hand this way. Well, as long as you always label from left to right, 0, 30, 45, 60, 90, or 0, 35, 40, 30, 45, 60, 90, it won't matter. Yep. So how about 45 degrees? What is sine of 45?
Well, 2 divided by 2 is 1.
Nope, the square root of the number of fingers to the left. So the square root of 2 over 2. Right, that works out. Now watch this. What about sine of 0 degrees? How many?
4.
No, how many fingers are to the left of my thumb that's down?
0.
Hopefully none. I don't have any hiding up my sleeve. That'd be weird.
Unless you're mutated and you
Yeah. I don't know. Yeah, I remember someone telling me they had a math professor with 6 fingers, so it is possible.
Just chop it off.
Yeah, I hope he uses a base 12 counting system instead of 10. So there are 0 fingers to the left of the thumb. What's the square root of 0? 0. What's 0 divided by 2? 0. So sine of 0 degrees is 0. What is cosine of 0 degrees? Fingers to the right are 4. Square root of 4 is 2. 2 divided by 2 is 1, right? And how about 90 degrees? Let's see. Right? Sine? Yeah, it is kind of tricky. Man, my hand hurts. Let's see. So sine are the square root of the number of fingers to the left. There are 4 fingers to the left. And square root of 4 is 2. 2 divided by 2 is 1. So sine at 90 degrees is 1. You got it, dude. Both of them are always divided by 2. And cosine, there are 0 degrees to the right, or sorry, 0 fingers to the right. Square root of the number of fingers divided by 2. Yep. So square root of 0 divided by 2, cosine at 90 degrees happens to be 0. All right? So for all of our special angles, you're able to use this hand trick. I think it works kind of nice. I actually also have a piece of paper that I'm going to pass out. This is actually from one of my college professors. Well, this isn't his trick. This trick is actually known pretty widely across the field of mathematics. But yeah, I think his pinky is better than mine. His pinky is just king pinky. Yeah, that's pretty great.
You use the right hand. I use the left.
Here, actually, there's one for Kim. Yeah, just one apiece. So you are expected to have these memorized, but with the hand trick, it doesn't make it that difficult. And there's even some examples on the back. Yeah.
weird because I don't think if that's his right hand, I don't think he can bend it back this way. What? What are we looking at? Look, I don't think
So,
look, you can't bend it down like that. What are you talking about? You can't bend it down like that.
so let's do one more example.
You're using
So let's do an example combining some of these. What is cosine of negative 120 degrees?
I don't have that many fingers.
No, we don't.
Dylan.
So let's draw a picture.
Oh, let's wait. What happens if you go on the right hand? What happens if you do
Don't mess it up. It'll mess it up. So negative 120 degrees is about here, right? So negative 120 degrees. Now, in order to find a reference angle, I first have to find a coterminal angle that's positive and between 0 and 360. So what is the coterminal angle in the positive direction?
240.
That's 240.
Whoa, I'm dizzy.
So this is the same as cosine of positive 240 degrees. All right, negative 120 is the same as 240. Now, what is the reference angle of a 240 degree angle?
Right there. It's 90.
I find that by doing 240 minus 180, right? If I subtract this part, right, these two yellow parts add up to the blue part, so this little yellow part minus the big yellow part will give me the scrap, all right? So I get 60 degrees, I believe. And now question, is cosine positive or negative in this quadrant?
It is negative.
It is negative, yes.
Yeah, see, even though I didn't write that down.
Yeah, right, because cosine is the x-coordinate of my point, and this point would have been going to the left, so x would have been negative.
No, what's X and what's Y?
Cosine is x, sine is y. So, friend, quiet please, follow along. Friend, come on. Excuse me, sir, this is live right now. I'm trying to,
Xbox Live?
yes, I'm trying to teach this here. That'd be great.
M. Sorry.
So negative cosine of, what's the reference angle? 60. So let's do our hand trick here. So this is going to be negative. What is cosine of 60? Put down my 60 degree finger.
1.
Cosine. So it's the square root of 1 over 2, which is 1/2. Okay?
Sin is
Fingers to the left.
3.
Alright, so this isn't that bad. I think it works out. So, I think we're good. We'll do some party work, and bye, Internet.